calculating the tangent, and you see that how tangent moves here. And entire calculus we try to achieve this thing, entire calculus in differential equation or differentiation. This is the thing we want to obtain. Okay. Now, what is the integration? You know how we can do that? And next I will be doing this integration. You see what I want to show, that how simple all this integration and differentiation is. You same thing we have done, same formula we have used, and we have calculated dx. And
when you take the slider value, the increment, can that increment value be picked up from a cell?
Increment value you are this
defining in the control panel. Yeah, but can that value be specified?
No. So you have to make some tricks. I am doing that tricks. I am doing. So
then automatically
you cannot put their negative numbers, but sometime I want to slide. So what I am doing, I am referring that cell and minus something, so that if it is 0, then I will get minus 50, suppose minus 50. So like that, and I want to, if it is minus 0.5, then I am dividing by 100. Now this is the thing for integration. Integration you have x, and similarly you calculate y, same formula, then calculate dx. Dx means y x2 minus x1, and then y into dx is the your area, y into dx is the area, and integration is nothing but calculating the area, and this go on summing this last column. Anybody if you can reproduce this, this is the integration, what we will get? Cumulative sum. Yeah. So, our curve was to some extent like that, and we are trying to calculate these areas, and all these values are y values, and this is the x value, dx value. So, this length and this breadth, you can say this is giving area, and combining all this you are calculating, and you are getting the area of this thing, your objective is there. So, you earlier dy dx you are getting this slope, and now you are getting this area, that is all, integration and differentiation.
And after it crosses that, again it will be the area.
And when you do it in analytically, you will be not knowing, in this case this area and this area it will be 0 if you integrate calculate, because this is a positive, this is a negative, but if you plot and calculate, you will immediately know that it cannot be 0. So, you will be knowing this area plus this area is negative side. So, these are the things in visual.
Area is a vector, no, it's got a sign to it.
No, area is not a vector.
No, area, when you compute it, otherwise how will you say this area plus this area is 0?
When for formula you calculate from this point to this point, integration of minus 2 to 2 and dy dx, you may get 0, because this is the but if you calculate in this fashion, you will immediately notice by graph that it cannot be 0, it is having area, it is having area. So, it will be different than 0, and then you can correct. Actually, you will here you will get all minus y, no, minus y into delta x, all are minus sign. So, area will be a minus 1. So, this is the thing, and last thing I want to show that this is whatever I have told, if you can apply it judicially, 90% of your mathematical problem you can handle, 90%, even vectors and complex analysis, because of this 3-dimensional cube I have shown, that will help you in exploring all these fields, and this is all single dimensional object you can calculate from this. But one issue is still remain, that 10%. What is that 10%? 10% is, earlier I have not told that there is x is y is dependent on x, a single valued function. So, single valued नहीं, single variable, sorry. So, here what was the issue? Now, coming again that domain and range, this was your domain x, and this is your range, but now it is a multi-valued multivariable function. Then how you will plot that?
Surface.
So, you cannot do that in 2D, you require a 3D surface. So,
So, your
this will
scatter
be
plot
your
goes-
x as usual, this will be your y. So, suppose this will be like that. Earlier we are telling no 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 like that, and corresponding y you are calculating, but now you have multiple. So, it will be like that. So, this is 0, 0, 1, 2, 3, 4 something like that. So, this will be your grid, and for every grid you are telling it is function of x and y both. So, every point you will have a value, is not it? But how we will do that? Yes, you have to plot in Excel.
So, how will plot in Excel? Surface plot is not existing in Excel.
Surface plot is there.
That's with
Yes. So, that will not help.
I don't know.
Okay, let us explore that option. So, with this
X এর জন্য তুমি y টা ডিটারমিন করতে x এর জন্য এই ভ্যালু
you can show here, sir. That will be fine.
Okay, what Chanchal is trying to tell you is, in our early case we had this x variable, your y is equal to fx situation. Okay, x was an independent variable, the variable whose values you could have chosen without any restrictions. Now, why the dependent variable? Once you choose x, the y value gets determined by it, so it depends on. So that we could have very easily have plotted. So I know, pick up whatever my value is, say 2 x value. Depending upon whatever is the computation here, relationship, the corresponding y value will get determined. So my p value will be 2 and whatever is the corresponding f of x. Now the next scenario that he is talking about is y is equal to x1 x2. Okay, it's no longer one variable, one independent variable. I need two. Now, okay, suppose I could represent this same axis, two variables. The earlier yesterday's session we had mentioned, right? So we could have used the same number line for representing the two. So I have called this x1 and then assume there is another x2 value over here. Okay, and now where is this y going to be? Somewhere over here. So obviously this is 2 and then assume this one is say 3 and corresponding y value will be somewhere over here. So some way of linking these two and then projecting a point here. So obviously this is getting complicated.
Yeah. So,
difficult. So let us instead create our axis and say this is x1, the trick that we had applied last time, and then call this guy your x2. Now what does this plane represent? This plane is actually representing this grid x1 x2. Now where will your y value go? Assume this to be a perpendicular axis projecting outside this board if it is positive and inside the board if it is negative. Okay, so which means this is my y axis. So this will be 1 1. So point 1 1 y1 will be equal to f of the corresponding height over here Now the reason why I am jumping into this is exactly how you represent images. Okay, your intensity value at a particular pixel is going to be determined by the x coordinate, the y coordinate, and the corresponding intensity value. The intensity value Ixy will be your fxy, and it's a function of x and y, 2-dimensional. You can keep extending 3-dimensional, 4-dimensional, 5-dimensional. Only thing is you keep on increasing the number of independent variables.
Yeah, that here I will add that you cannot go on adding in this graph, this 2D, 3D. You cannot go on adding. You can add at 3D only, but you can extend this same concept to multiple variables. It will work. You need not devise a new system. You cannot display that. Display is difficult, but the formulas and the thought behind those things are same. It can extend. Now, how we will draw that in Excel? I will just briefly do that. You just do that. You just take as a x in one cell to 1, 2, 3, 4, 5, 6. You just put it these numbers. So, cell 1, cell 2, cell 3, cell 4, cell 5, cell 6. So, 6 cell. Okay? You put like that. Yeah. Because one thing if you learn, then you can extend it to anything. 1, 2, 3. Five, 6. So, you have 6 cells and copy this 6 . So, this is your x.